So this is about vector. I just want to do a very quick review. I said vectors have both magnitude, which is size, and direction. So you have to talk about size and a direction. And unlike scalar, which has only what? Magnitude with no direction. Now, when you're looking at vector, you need to consider what we call position vector. The position vector is a vector measured from the origin. The origin is the reference point. In the question, they usually indicate the origin with 0. O, which is like a point where you will measure all vectors, we will take as your reference, point of reference. So the position vector is a vector measured from that origin, which is the reference point. Let's look at this vector. Can you attempt this? Not at all. It's one mark question for each, so it shouldn't require much. Let me zoom it in a bit to capture, zoom out a bit. So it says O to A is 5A, O to B is 3B, and M is the midpoint of AB. So find in terms of A and B the vector AB, the vector A to B, that's moving from A to B. If you're moving from A to B, the thing about vector is if you're moving in any direction, you follow the direction that is known direction. I'm assuming this is a city A, whatever the name is, city A, and this is another city, city B, and you want to move from city A to city B. You are only going to go through directions that are known, directions that are given. This direction is given. This other direction is also given. Those are the directions you follow. So if you are going to move from A to B, you're not going to just walk from A to B like that, because this direction is not known. You're only going through the directions that are known or given. So this and this. Are you getting what I'm saying? Are you still there?
Wait, so is it?
Okay, so yeah, go ahead. So you will need to walk from A to O, because that's a route that is known or given, and then from A to B. So you walk this way, A to O and O to B.
Well, doesn't it say O to A?
Pardon?
Doesn't it say O to A?
Yes, I know. Yes, I know. It's O to A is given. But you know, the question asks you to move from where to where. Look at the question.
A to
You are going from A to B. So when you start from A, you first of all move to O. So it will be A to O before O to B. So what is
minus?
Go ahead, I'm listening.
Minus 5A.
Interesting. Because O to A, or rather A to O, A to O is minus 5A, then you do O to B. You want to come from A to B, you go through known paths or known routes. So A to O minus 5A, then O to B, 3B. So let's go. Write it down. Minus 5A plus 3B. You might want to also say 3B minus 5A. I hope you know it's the same thing.
What?
I hope you know it's the same thing as saying 3B minus 5A. It's the same thing now.
Aye.
That's positive 3B and then negative 5A. But this will also be marked. That's also correct. Now find in terms of A and B the vector AM, and M is the midpoint of A and B. So you are now going from A to M. A to M is just half of the movement you made earlier, isn't it? Did you get? Yes.
3b minus 5a divided by 2.
Interesting. So 3b minus 5a divided by 2. Because the whole of A to B is 3b minus 5a. So the other one will just be half of it divided by 2. Okay. All right. Then.
But when it's written at first, does it mean you start with like the letter?
You do what?
Like M. If it's O to M, you start with O.
If it is O to A, say that again.
If it's O to M, you start with O instead of A.
Yes, exactly. If it was O to A, you are going to start from O and move to A. The motion should go in the direction of the letters. O to A would have just been 5A. But A to O is now minus 5A. You already know that. Which other, I think it says find in terms of A and B the vector OM. So we're looking for this vector. OM. You know, moving from O to M, how will you go? If you want to walk from O to M, how will you go? You know, you have to follow known paths, isn't it?
No.
You have to follow known paths. How do you go? Let me see if the next question is on vector 2. All right. So let me zoom in a bit.
I don't know.
Yeah, you do. You do. Yes, you do. You want to walk from O to M, isn't it? Because the question is asking us to find OM, isn't it? Look at it, OM. You want to scroll down a bit? Okay, so we're looking for find the vector O to M. O to M. So we want to find O to M. To move from O to M, remember you are following known path. To move from O to M, what are the known paths, the known routes you can follow?
O, B, 5A.
That's O to A and then A to M, isn't it? First of all, you go from O to A, and then from there you come to M. So O to A, and then A to M.
You could just go from O to B to M.
Yes, you can also do O to B, and then B to M. That's also correct. You get the same answer.
How does that include A?
Pardon?
Like if you're doing O to B to M, how does that include A?
If you go from O to B, that will be 3B plus B to M. Whichever route you follow, you will get the same answer. But I think
so it's 3 plus 5A.
Are you writing this down?
Divided by 2.
I think it's better you write it down. Let me write it down first of all. O to M, I said, is you go from to move from O to M, you have to first of all go from O to A and then A to M. So let's write it down. O to A is equal to O to A plus A to M. OA plus OM at AM. And we know each of these. You know OA. OA is given, and you just found OM. Sorry, you found AM. What is AM you just found now?
3b minus 5a divided by 2b.
And you already know OA. You already know OA. What's OA? You already know OA. So, right?
I forgot how we got AM. I forgot how we got AM.
You forgot how we did what?
AM.
AM. Okay. AM. You know we found A to B. A to B was the first thing we found. See it there. What did we get A to B as?
A to B. No, I forgot how we got A to B.
That's straight. Okay. All right. A to B. A to B. I told you in vectors. It's just think of following routes that are known. It's like there are pathways that are already defined. So you follow the pathway to get to where you're going to. We're asked to move from city A to city B. We don't have any knowledge about this route. So we go through the routes that we know. So you move from A to O, which is minus 5A, and then O to B, which is 3B. A to O.
Oh, yeah.
And then O to B. That's how we got A to B. AB, we got the AB to be minus 5A plus 3B, or 3B minus 5A. And after that, we know that M is the midpoint of A to B. So you divide it by 2 to get A to M, to find A to M. Is that clear now?
Yeah.
So can you go ahead and substitute? Just do that, because I think there's another question on vector. You know, you need to understand this before we go to the other one. It might be simple too, but I think you need to understand this properly first of all. Let me allow you to finish up this before I move to that one. So, are you writing the values now? O to A plus A to M. What's O to A?
5A.
Alright, so go ahead. 5A plus A to M. What's AM?
Minus 5A.
This is AM. This is AM. You already have the value of AM. You're just putting it there. Simplify. Anytime you have this, you need to simplify it. So what do you do to simplify this? That's a fraction. This is like saying over 1. This is like 5A over 1. When you have a fraction like this, how do you simplify it? In other words, if you have 2 over 3 plus, say, 1 over 2, how will you simplify it? You raise them to a common denominator, isn't it?
Yeah.
This is going to be a long...
Why do you have to do that if it's only 1
Pardon?
Why do you have to do that if it's only 1?
Yeah, you have to simplify it. Anytime you have an expression like this, it needs to be simplified. Sometimes the question will require you to get those values in their simplest term, in their simplest form. So it should be simplified. Okay, first of all, 2 over 3 plus 1 over 2, what will you do?
Change both the denominators to...
Common denominators. So you will probably multiply this one by 2 and multiply this one by 3, isn't it?
Yeah.
2 over 2 and 3 over 3. So do the same thing here. Do the same thing here. I will always require that you use a different color marker so that when you're reading this, it doesn't get mutilated. So times 2 times... What did you multiply this one by?
1.
By 1, okay. Okay, so plus... Good. all over 2. So everything will now be equal to what? So everything is now over 2, and then you write that out because you raise them to a common denominator. So you now have plus 3b all over 2. So that's how it will be. Is that clear?
Yeah.
I'm on the second page. So point O is the origin. So any other point like P measured from O is a position vector. So O to P is a position vector. Another way of putting it is to say the position vector of capital letter P is what? This small letter P, because it is measured from origin. Also, the position vector of capital letter Q, make sure you're paying attention, is this small q, because it's measured from the origin. Position vector is a vector measured from where? Origin. What's the position vector of this capital letter Q?
Q.
Small letter q, because it is line OQ, measured from O, the origin. Now, look, this question says, find in terms of small letter p and q in their simplest form vector qx. Qx means from q to x, because the arrow is pointing to x from q. So we are going to walk from q to x. But if you are working with vector, I have said that you must follow known path. We don't know q to x. It's like a river. We cannot cross it. So we have to follow the path that we know that are given. The paths we know are the paths that are given. What are the paths that are given? Mention them.
Okay.
Say OP, which is small letter p, and OQ, which is small letter q. You can only follow this path to get to x. You can't walk from q to x. In fact, anytime you are dealing with vector, this thing I'm just saying now, if you just get it, you've gotten it. Stay alert, sit up properly. Very, very important. So I don't have to repeat this. This is very, very important and very key. What I'm saying now is very key. Beautiful. Once you have some paths that are already given, and you are expected to walk from a particular point to another point, go through the paths that are given. Go through those paths that are given. Don't just jump to the position you are looking for, because it's like there's no road there. In fact, q to x has no road. You can only get to x if you are coming from q. If you are coming from q, you can only get to x if you follow which road? Let's walk. I want to move from q to get to x. Which roads will I follow? Let's start from q. No, say it now. The letters are there. From q to where? First of all,
X.
I can't move from q to x because there's no road there.
O.
Good. Make sure you're paying attention. So you move from q to o first.
Isn't that what I said?
You said x.
O.
You move from q to o first,
Yeah.
and then I
O
move.
to P.
You move from o to p, and then
And P to X.
then p to x. Once you've done that, you've gotten to x. This is how we solve vectors, and it's so easy. Did you see that? Yes. I'm moving from q to x, but there's no road there. But I know some paths that are given that I can follow. I can follow q to o. From o, I move from o to p. From p, and I move from p to x. And I get to x.
X.
Okay. We have a little challenge. The challenge is we are giving o to q. We are giving o to p. But we don't have p to x or even p to r. But do you know that we are told that this is a parallelogram, right?
So I thought we were reading.
I want to review all this so that we move along.
Okay.
This is a parallelogram, isn't it?
Yeah.
Being a parallelogram means which two sides are parallel to each other. For instance,
All the sides.
not all the sides are parallel to
Yes,
each
so
other.
the two.
You mentioned them.
Okay.
Q to R and R to
Say that again.
Q to R and
No, you need to be specific.
Q to
O to Q is parallel to what?
P to R.
P to R. O to Q is parallel to P to R. Being a parallelogram. So if the two are parallel, they are also equal. That is because it is a parallelogram. Opposite sides of a parallelogram are parallel and also equal. So since the vector of OQ is small letter q,
Okay.
the vector of PR is also small letter q. Is that noted?
Yeah.
So
Because
I'll go-
PR is, yes, parallel and equal to OQ, being a parallelogram. Yes, I want to hear you out.
So O to P.
O to what? O to P is parallel to what again?
P to
Q to R, yes. O to P is also parallel to Q to R. It might help us. O to P, have you observed that? O to P is also parallel to Q to R. So let's even write it down. It may be helpful. Let me write it down. What is QR? What's the value of Q to R?
P.
Small letter P. Interesting. You see that? This is how we get all this. It's small letter P. Once you master this, you're good to go.
So don't you come to my school?
Yes, let's go. You see, I tell you, this is the principle, and we have gotten this answer. As soon as we have all these values, wherever we are going to, we have it. We have it. All right, there's another statement. Read this statement I'm underlining. The third line.
X is on PR.
Answer anything.
X is on PR so that Px is equal to 2xr.
Yeah.
P to X is what?
2x.
2xr. What does that mean?
That means P to X
Is double of
is double
of x to r. P to x
Come back to that.
is double of x to r. Did you get that?
Yeah.
P to x is double of what? X to r. Now this is important. Stay here. P to x is double of x to r.
To R.
Is given in this statement. I like this. It's getting clearer.
No, it's not.
You see, it's getting. Just watch it. Watch me. P to x is double of x to r.
Just Q to X.
Now, I'm showing you. Make sure you're looking at the screen. P to x is double of x to r.
But then we know P to R.
There's no P. We already know what P to r is now. We know it's q. Small letter q.
I don't understand.
I just told you that x is on PR so that px is 2xr. Px is 2xr. What does that mean? P to x is double of x to r. Did you see that? Yes, because it says, read this this last sentence. This sentence
Q is on PR.
no, x is on,
X is on PR.
bless you, so that px is equal to 2xr. So if you measure from P to X, it is double of what you measure when you take the length of X to R. It's stated here, Px is double 2 times. Are we good on that?
Yeah.
Can I move on?
Yeah.
So 1 is double of the other.
Yeah.
So they are in the ratio of 1 to 2. No? You can
No.
think of that. Yes, you can actually think of that.
So I
In the
know
ratio
what
of, no, now they are in the ratio of 1 to 2. In fact, what it means is, let me show you something. Let me just show you. If I divide P to R in 3 places, what can I use to divide this? Let me use this, my red line. Divide it in 3 places. Here, here, and here. How many will Px pick? I have divided P to R in 3 places. How many will Px pick?
3. 2.
Px will pick 2. While Xr will pick only 1. Because it is double of it. Whenever you hear something like that, like you say 1:2, divide it into 3 quarter. It's just like we do sum of ratio now. 1:2, what's the sum of ratio? If I write 1:2, what's the sum of ratio? Talk to me, what is the sum of ratio in 1:2 when we are doing, what's the sum of ratio?
3.
3. So you divide it into 3 equal parts. The one that is bigger will take 2 parts.
So,
The one that is smaller will take 1 part.
So I don't understand. Angel doesn't understand.
I just said it now. Look at, I said one is 2 times of the other. So it is 1:2. What is the sum of ratio in 1:2? 3. So what does it mean? Divide it into 3 equal parts. The bigger one will take how many parts?
One.
The 2 parts. While the smaller one will take 1 part. That's what it means. What are we even dividing? The whole length. What's the whole length, by the way? What's the whole length of PR?
Q.
The whole length of PR is Q. That's what we're dividing into 3 equal parts. The whole length of PR is Q. And that's what we're dividing into 3 equal parts.
Yeah.
So PX ratio XR, we are given PX is 2 times of XR. You are seeing it as I'm circling it. So PX we collect 2, XR we collect 1. So what's the sum of ratio? 3. So it's like dividing into 3 equal parts. Just the same way you do ratio. Assuming these 2 people are sharing, let's even say they are sharing 15 pounds or $15, 15 pounds. They are sharing 15 pounds. 2 of them are sharing 15 pounds. How much will PX get? We know ratio. How much will PX get? We've done ratio now. How much will PX get? They are sharing 15 pounds. How much will PX get?
10.
Beautiful. How did you get that?
2.
2 out of the sum of ratio
10.
times what they are sharing. You see how easy these things are. It's not something you cannot get if you just pay attention. So PX will get 2 because its own ratio is 2. Out of the sum of ratio 3 times what they are sharing, 15. Why QR will get what? What will QR get? Tell me what QR will get. What XR will get. What will XR get? How did you get that? 1 out of 3 because its own is 1 and the total thing is 3 times what they are sharing, 15. Assuming it's an assumption that they are sharing 15 pounds. But what are they really sharing? What is the length of line they are sharing? What is the length of line they are sharing? We know that now. What's the length of line they are sharing? What is the length of line they are sharing, or the vector that they are sharing? It's written there now.
I can't see what you're showing.
Are you sure you're on page 2?
Yeah, okay. I can't see.
What is the length of line they are sharing?
Q.
They are sharing Q. I use this 15 as an instance. But they're actually sharing Q. So you will share it the same way we shared 15 between the 2 of them. So let's share Q between 2 of them. It's actually Q they are sharing. Right?
Yes.
Okay, so let's share the Q between 2 of them. Don't ever think any concept. You see, I'm pouring out my heart to you because that is a reality. The truth is this: there's no concept in math that is beyond your understanding. What you need is the principles. As I'm laying these principles out to you, I started first of all by telling you the most important principle. If you are moving from anywhere to anywhere, don't just go there, because there's no road there. There's no road from Q to X that we are asked to find. There's no. How do I know that there's no road? They didn't give us any vector there. So which road will you follow? The ones that are given. And thank God you already told me that we are giving O to Q, so I will follow that road, O to Q. We are giving O to P, so I will follow that road, O to P. We really didn't know Q to P to R, but we know that it's a parallelogram, so P to R is also Q. And then there's another information, that this P to R will be shared by two people, PX and XR, in this ratio. PX will take the bigger share, double. XR will take the smaller one, 1. And I said, if they were to share 15 pounds, you will share them share the 15 pounds like this, using the principle of ratio. So since they are sharing Q, let's share Q between the two of them. They are sharing Q, so this one would have gotten 2 over 3, is it not? 2 over 3 times Q, is it not? What is 2 over 3 times Q? That's 2Q over 3. What will XR get? So let me write this all. Remember, if it was 15 they were sharing, it would have been 2 over 3 times 15. 2 over 3 times 15. Now, since they are sharing Q, it's going to be, so I will just say or. So hold on, let me write it below it. It's going to be or 2 over 3 times the real thing they are sharing, which is Q. What is 2 over 3 times Q? Give me the answer. What is 2 over 3 times Q?
Are you sure it's the try calculator?
That's 2Q over 3 now. You don't need to do any calculator with 2 over 3 times Q is simply 2Q over 3. So that is what PX we get. That's the value of line PX. That's the value of line PX. That's equal to PX, P to X. That's P to X, you know. P to X is 2Q over 3. What is X to R? Use the same principle. What is X to R?
1 over 2.
1 over 3Q. 1 over 3Q, you know, because it would have been 1 over 3 times 15 if it was 15 they were sharing. So it will now be 1 over 3 times Q. So I can also say or 1 over 3 times Q, or let me just write it as XR, because we may need it later, so I better write it down. So XR is equal to 1 over 3Q, or I could have just said Q over 3 instead of wasting time, because 1 over 3Q times Q. All right. Here we are. We have all we need, at least for this question. What's the question again? Read it again. What are we asked to find? What are we asked to find? Listen. QX. QX. So let's go. You start from Q. How do we even get to X from Q? Me again. Q to O. And from O, where do we go? O to P. From P, where do we go? P to X. We land at where we are asked to go to. That's QX or Q to X. So we go from Q to O. Let me write it down now. So this is how we move. We go from Q to O. Then from Q to O, we go from O to P. From O to P, we go from P to X. So tell me, what is Q to O? That's why I wanted you to pay attention, because there's something here you must be careful about. What is Q to O? You tell me, what is Q to O? Go ahead, I'm listening.
Q to O.
Yes.
I don't understand.
No, yeah, what's Q to O now?
Q.
It's actually not Q. It is O to P Q that is Q. O to Q. O to Q is Q. But now we are moving backwards, Q to O. Because vector is interested in direction, or direction is important in vector. Yes, O to Q is Q. But now we are moving Q to O, as you can see. Let's see. Q to O. So what's the value of Q to O? Opposite. So it's not just Q, it's minus Q. Get it, my people? This is minus Q. Plus, what is O to P? I think O to P is the right thing that is given here, is it not? We are going in the same direction. So O to P is what? Give me now the thing stated written there. What is O to P?
P.
P. O to P is P. Plus, what is X to R? What is P to X?
Minus Q.
No, P to X is given. We found it. That's exactly what we're struggling to find all this while. I think I should even write it down here, so that it will come out better, which is equal to P to X. That's what we tried our best to find here. P to X. We found it now. That's 2Q over 3. That's all we did here. P to X. See it? P to X. That's all we did here. We used an example, $15, and we changed it to what it is. It is exactly Q, and we found 2Q over 3. So P to X is 2PQ over 3. You know. So that's PQ over 3. 2Q over 3. 2Q divided by 3. So our work is just to simplify this, because it says in their simplest form, and you get your full mark. So let's simplify this. This is 2Q over 3. Your understanding of arithmetics is important here. So you have minus Q plus P plus 2Q over 3. How do you solve the equation, like solve this kind of algebra? This is 2Q over 3. You use the LCM. I hope you know that this one is like saying over 1 over 1. What's the LCM? What is the LCM of the denominators 1, 1, and 3? What's the LCM?
The LCM is.
You had better pay attention. You had better pay attention. The LCM is 3. You know, when you are solving fractions,
No shame.
when you are solving fractions, you can look at this one. When you're solving fractions, you use LCM. You raise them to the same denominator. What we had originally was minus Q plus P plus 2Q over 3. Minus Q plus P plus 2Q over 3. That's what we had originally. And I said, you solve it the way you would have solved. Think about it. If you're given minus 2 plus 5 plus 1 over 3, how will you solve this? Look at what I just wrote here. Minus 2 plus 5 plus 1 over 3. That's arithmetic now.
Oh, use calculator.
Then you can use a calculator here. That's why you need to be careful. You must learn all these things. You can't bypass them. You can maneuver your way around it. You do normal arithmetics. Use LCM. What's LCM?
You said
3. 3 into 1, or 3 divided by 1, 3 times 2.
Minus 6.
That would have given us minus 6.
Plus
Minus 6
plus 15.
I'm just using this as an example, just like I used the other one now. So you also say 3 divided by 1, that's 3 times 5, so plus 15. Also 3 divided by 3, 1 times 1, that's plus 1. So you get your answer. Perhaps this one would have been something like, so I'm using this recall in case you have something like this. This is what you would have done, and you get your answer. So we're applying the same principle here. We're applying the same principle here. You know what we want to add was minus q plus p plus 2q over 3. So let's apply the same principle. The LCM is 3. So 3 divided by 1 times q
Minus 3q.
minus 3q. So that's minus 3q plus
3p.
3 divided by 1, 3 times p, that's 3p plus
2q.
3 divided by 3, 1 times this, that's 2q. So what should be the final answer? Simplify. What will you get? Minus 3q plus 2q. What will it give you? You owe 3
Minus 1.
minus 1q. So 3p is better to write the positive one first. So that would be 3p minus 1q, which is just q,
South.
over 3, which is the answer. Yes, please.
Yes.
Okay. Just a moment. Let me conclude this. Let me conclude this so that we can move on to. Give me a few seconds. Let me just conclude this. It will be helpful if I can conclude this. Right? So we've gotten this. Now the second question says the position vector of M, the midpoint of QX, the position vector of M. Do you remember what I told you about position vector? It has come to play now. What did I say about position vector? The vector measured from origin. Let me show you again. Read it out again. It's on page 1. You can read out what I have on my own page.
Yes,
Position vector is the vector measured from the origin O. So the question says we should find the position vector of M. The position vector of M, and M is the midpoint of QX.
This place.
Okay, so position vector of M. Then, if you like, you can draw a line from O to M. That's what we need. That's OM. It's basically asking you to find OM. In other words, find OM. Find OM. Because position vector is measured from the origin. So we're looking for OM. So we have to find OM. How do we find OM? It's easy. That's actually true. It's actually easy. We found QX. We found QX, remember? What did you get QX as? I think I need to write this thing out properly using a black marker.
3p minus q.
We got QX as 3p minus q over 3. Don't forget that 3p is what is left here. And minus 3q plus 2q give us minus q. That's how we got the minus q over 3. That is QX. Let me actually write it. What's that again? QX, yes. So QX is this. And we are asked to find O to M. O to M. Now, how will you go from O to M? Let me ask you. Remember, O to M, nobody knows that road, though. So you have to follow the road that you know. Follow the road that you know and go from O to M. How will you move if you were to move from O to M? Don't forget that you have to follow the road that you know How will you get to M? Yes. I'm moving from, I'm at O. Somebody needs me to get to M. And there's no road from O to M. So I have to follow the path that I know. That's the way we do vector. So how will I move?
I don't know.
Yes, now is this place not given? OQ is given. We know OQ. We know that path. What's the value of OQ, by the way?
Q.
Small letter q. And we found qx. Remind me again, what's the value of qx? P minus q over 3. 3p minus q over 3. And they say this place is the middle point of it. So that means qm is just half of the whole thing. Qm is half of everything. Qm is half of everything. You may want to even find qm. Qm, which is half of everything. We don't even need to. Qm is half of everything, so we can get qm first. So let's get qm first. Qm remember qm is half of what? Qx. Qm is half of qx because m is the midpoint. Is half times qx. That's what I'm telling you. Did you just see what I wrote? Qm is half times qx. Q to m is half of everything from q to x. And we know q to x, so we just multiply it by half. So let's multiply it by half. What do we get? So half times all this 3p minus q over 3. Your understanding of simplification of algebraic expression, which is a previous lesson we had. So what I'm saying is half times qx, and this is qx. So half times qx. Half times this, what will it give us? 2 is down, 3 is down. So they are the two that will multiply themselves, each other, right? What would that give you? 3p minus q over 6. That's qm. Qm itself is this. So we know qm. Our work is almost done. Remember, the equation is find the position vector of m. Position vector of m, where m is the midpoint. Find the position vector of m. And I told you position vector of m is from O. So we are coming from O to m. We're coming from O to m. So to go from O to m, we have to walk from O to q. You know, you want to move from O to get to m. There's no road here. You follow the road, you know, O to q, which we know as small letter q. And then now from q, you go to m. So we do O to q and q to m. O to q and q to m. So OM is equal to O to q. OM is O to q. Then q to m. Thank God we've already found what q to m is. So let's just add. What is O to q? What's O to q? That's small letter q now, is it not?
Yeah.
So that's q, small letter q, plus what is q to m? That we have it here. 3p minus q over 6. What do we do again? Is a fraction, because all of these things must be, anytime you find a vector, even though it is not stated, always try to leave it in its simplest form. Because it must be in its simplest form, so you must simplify. That's why simplification of algebraic expression is important. I've treated that in a previous lesson. So this, you can call this one, anytime you have a number, something without anything under it, just call it over 1. What's the LCM? What's the LCM of these two? LCM
Six.
of 1 and 6 is 6. So the LCM is 6. So we also said 6 divided by 1, 6 times q, 6q, right? Plus 6 divided by 6, 1. It's better to put that one and open a bracket and write this, because if there's a minus there, with this bracket it will be safe. This is what I did. Let me show you again. 6 divided by 6, 6 divided by 6 is 1. And you know you're going to use that 1 to multiply everything here, is it not? That's why I wrote the 1 and opened the bracket for this. This is what we call composite function. Always write it in a bracket. The reason is this: if there was a minus here, everything would have, some things would change. So put it in a bracket so that you don't mistakenly write something and forget how they really multiply that. I will just explain that very quickly. So remember, it's a plus, so we may not even fall for that trap. But if it was a minus, you needed to be careful. So let's go. This is 6q. So that gives us 6q plus 1 times 3p. How did we even get this one? Do you remember?
Yeah.
From 6 divided by 6, 1. And we're going to use the 1 to multiply everything here, is it not? Whatever sign you have it, you must also add it here. So that will give us this 6q, I've written it out, plus 1 times 3p is 3p. 1 times minus q will give us minus q all over 6. So the final answer will be what? 6q minus q is 5q plus 3p all over 6. So this is the answer. If this place was a minus, let me just ask you, supposing this was a minus, if this was a minus, you would have done minus 1 times 3p. That would have given us minus 3p. Then minus 1 times minus q. This place would have changed to plus. If this place was a minus, you know, whenever a minus is opening a bracket, the sign inside the bracket will change. If this was a minus, this sign here would have changed to a plus. That's why you need to write that so that you remember. We did all that in simplification of algebraic expression.